In this video, I'm going to be looking at the solutions to the systems from the extra set of review problems. So I'm going to jump over here. I've rewritten that first equation. Remember, the whole idea when you're solving a system is you've got two variables. You can't solve an equation with two variables, but if you can get down to an equation that has only one variable, then you can solve it using regular algebra techniques. So because y is equal to 2x minus 4, y is the same thing as 2x minus 4, I'm just going to replace the y in the other equation with that 2x minus 4. This would be the substitution process. And in this particular case, we would have the x staying where it is. The y is being multiplied by 4, the entire y value. So I'm going to put parentheses here, take the y out, and put the 2x minus 4 in place of it. And then the whole thing is going to be equal to 29. So this is the same equation, x plus 4 times y, but y is the same thing as 2x minus 4 equals 29. And then we can solve. So we have x plus 8x, if we distribute, minus 16 is equal to 29. We can combine some like terms here, and we end up with something that looks like that. We can add 16 to both sides, and I believe that's 9x equals 45, which means that x is going to be equal to 5. Okay, once you find x, you can sub it back into one of the equations to find y. I would put it into this one here. 2 times 5 is 10. 10 minus 4 is 6 for my y value. So first equation here, we get x equals 5, y equals 6. And if you have time, I'd encourage you to check in both equations. For example, 4 times 5, if we had 5 in this first position, 4 times 6 is 24. 5 plus 24 is 29, and you can see that it works. All right, example number 2 here. I think I actually have enough room to do this one on the paper, so I'll do it right here. Notice that the x's and y's are already lined up. I think it would be very hard to solve for either the x or y variable. So I'm just going to pick a variable to cancel. I'm going to cancel the x's. It doesn't matter. You can cancel x's or y's. I think it's going to be similarly easy here. And remember, you're looking for a number that both of the coefficients divide into, because then you can multiply both or one of the equations by some value to create a cancellation. 3 and 5 both go into 15. Okay, so I'm going to try to get a 15x here. The way I'm going to do that is I'm going to multiply my top equation by 5, and I'm going to I'd like to get a negative 15 from my lower equation, so I'm going to multiply the lower equation by negative 3, and that'll give me a positive 15x and a negative 15x. So remember, everything in your equation, all parts, need to be multiplied by 5. So that's going to be 15x minus 10y is equal to negative 45. Second equation, everything gets multiplied by negative 3. We're going to get negative 15x minus 9y is equal to negative 12, okay? If you have the same signs, you should subtract the two equations. I have opposite signs, so I'm going to add. 15 plus negative 15 is 0. Negative 10 plus negative 9 is negative 19y. And let's see, we're going to get a negative 57, okay? 19 goes into 57 3 times. So y is going to be equal to 3 here. And then to find your x value, you're just going to need to sub back into one of the original equations. It really doesn't matter. I'll take that top equation. The top equation is 3x minus 2 times the y value. We now know y is 3, and it's supposed to equal negative 9. So that's 3x minus 6 is equal to negative 9. If you add 6 to both sides, you'll get 3x equals negative 3, which means x is going to be negative 1. I'm running out of room here, but I think you can probably finish that part. All right. And the last equation down here, I'm noticing that, first of all, the x's and y's are not lined up. Okay, so I'm going to keep the original equation like it is. 6x minus 2y is equal to 8. That second equation, I need to move the y over here by adding y to both sides. And I need to move the 5 to the other side by subtracting 5 from both sides, and that's a mess. We're going to get negative 3x plus y is equal to negative 5. And that's the new equation that I'm going to use for that second part. Now, if we take a look over here, I've recopied this. I'm noticing if I have a 6x here and I have a negative 6x there, I could get a cancellation. I could just multiply that second equation by 2. So the first equation doesn't even need to change. And the second equation, if we multiply everything by 2, we're going to get negative 6x, we're going to get positive 2y, and we're going to get a negative 10. And you'll notice that something not great happens. When we add our two equations, the x's cancel, which seems great, but then the y's cancel. I'm just left with 0 over here, and then we get negative 2. If your variables cancel and you get a false statement, something like 0 being equal to negative true, which is obviously not true, that's a no solution case, okay? That is a situation where we actually had two different equations that were parallel, and so the lines would not intersect. If we graph them, there's not going to be a solution, okay? If you get all the variables canceling and you get a true statement, maybe like a 0 equals 0 or that kind of thing, that's a situation where you really just had the same equation written in two different forms and everything canceled because it's the same equation. And in that case, because it's the same equation, every point on either line is a solution to both. So you would say that there are infinitely many solutions, or if you needed to list one, you could pick any point on either line and it would work for both. Okay, that's the idea. Now this next one here. All right, we're told that ABC is a right angle, so that's already labeled in the diagram. If you need to remind yourself of that, that means it's 90 degrees. ABD is congruent to DBC. So they're saying that this angle here is congruent to that one here, which, by the way, means that they're both going to be 45 degrees, which I'm going to label. I don't know if I'm going to need that or not. The measure of angle ABC, which is the big angle, is 2x plus 4y plus 10. Okay, and then the measure of angle DBC is 2x minus 3y, and that's that lower one. And I need to write an equation here, okay? So the one that really jumps out at me, that original angle is a right angle. And so let's take a look at that one first. That means that this is going to equal 90. So in other words, 2x plus 4y plus 10 is going to be 90. I would get the 10 to the other side and write that as, that'll end up being 2x plus 4y is equal to 80. That's one of my equations. And then we're going to come back here. Now, you could label both of these angles as 2x minus 3y, and you could say that 4x minus 6y is also equal to 90. But because I knew that the little angles were 45, that means that 2x minus 3y is going to be 45, and I would just use that as my second equation. That can be pretty straightforward. Another reason you're going to see over here, I can actually just subtract the two equations, and that'll cancel the x's. Or if you don't like subtracting, multiply one of the equations by -1 to switch the signs. But anyway, 2x minus 2x is 0. Be careful, 4y minus -3y. That ends up being plus a 3y, which is 7y. 80 minus 45 is 35. Okay, 35 is divisible by 7. Y ends up being 5. If I want to find my x value, I can substitute back into one of the original equations. So if 2 times x plus 4 times the y value of 5 is supposed to equal 80, we get this equation. 2x plus 20 is 80. That means 2x is equal to 60, which means x is equal to 30. And those are my x's and y's. And the problem just said to find x and y. So looks like we're done here. X is 5. Y is, x is 30. And y is 5. And that's all we need there.